Mathematics and cryptography have been intertwined for centuries. The art of secret codes has been used throughout history to protect sensitive information from prying eyes. Today, we will explore the fascinating world of mathematics and cryptography. Cryptography is the science of secret communication. It involves the use of mathematical algorithms to encrypt and decrypt messages. These algorithms are designed to make it difficult for unauthorized parties to access the information. Mathematics is the foundation of cryptography. Without mathematics, it would be impossible to create the complex algorithms that are used to encrypt and decrypt messages. In this video, we will explore the history of cryptography, the different types of encryption methods, and the role of mathematics in creating these methods. So, sit back, relax, and let's dive into the fascinating world of mathematics and cryptography. Cryptography has been used for thousands of years. The earliest known use of cryptography dates back to ancient Egypt, where hieroglyphs were used to hide secret messages. In ancient Greece, the cipher was used to encrypt messages. The cipher was a rod with a strip of parchment wrapped around it. The message was written on the parchment, and when unwrapped, it appeared as a jumbled mess of letters. Only those with the correct rod could decipher the message. During the Middle Ages, the use of cryptography became more widespread. The famous Caesar cipher was used by Julius Caesar to encrypt his messages. The cipher involves shifting each letter in the message by a certain number of places in the alphabet. In the 16th century, the Wagner cipher was invented. This cipher used a keyword to encrypt the message. The keyword was repeated over and over again, and each letter in the message was shifted by the corresponding letter in the keyword. During World War II, the Enigma machine was used by the Germans to encrypt their messages. The Enigma machine used a series of rotors to encrypt the message, making it incredibly difficult to decipher. Today, cryptography is used in many different applications, from securing online transactions to protecting national security secrets. In the next segment, we will explore the different types of encryption methods used in cryptography. There are two main types of encryption methods used in cryptography: symmetric encryption and asymmetric encryption. Symmetric encryption, also known as secret key encryption, uses the same key for both encryption and decryption. The key is kept secret between the sender and the receiver. Asymmetric encryption, also known as public key encryption, uses two different keys for encryption and decryption. The public key is used for encryption, and the private key is used for decryption. One of the most widely used symmetric encryption algorithms is the Advanced Encryption Standard AES. AES is used to encrypt sensitive information, such as credit card numbers and passwords. Asymmetric encryption is used in many different applications, such as securing online transactions and protecting national security secrets. One of the most widely used asymmetric encryption algorithms is the RSA algorithm. In addition to symmetric and asymmetric encryption, there are also hash functions. Hash functions are used to create a fixed-length message digest from a variable-length input. In the next segment, we will explore the role of mathematics in creating these encryption methods. Mathematics plays a crucial role in cryptography. Without mathematics, it would be impossible to create the complex algorithms that are used to encrypt and decrypt messages. One of the most important mathematical concepts in cryptography is prime numbers. Prime numbers are used in many different encryption algorithms, such as the RSA algorithm. Another important mathematical concept in cryptography is modular arithmetic. Modular arithmetic is used in many different encryption algorithms, such as the Diffie-Hellman key exchange. Cryptography also involves the use of complex mathematical equations, such as the elliptic curve equation. The elliptic curve equation is used in many different encryption algorithms, such as the elliptic curve cryptography (ECC) algorithm. The use of mathematics in cryptography is not limited to encryption algorithms. Mathematics is also used in cryptanalysis, which is the process of breaking encrypted messages. Cryptanalysts use mathematical techniques, such as frequency analysis and brute force attacks, to break encrypted messages. In conclusion, mathematics is the foundation of cryptography. Without mathematics, it would be impossible to create the complex algorithms that are used to encrypt and decrypt messages. In the final segment, we will explore the future of cryptography and the challenges that lie ahead. The future of cryptography is constantly evolving. As technology advances, new encryption methods and algorithms are being developed to keep up with the changing landscape. One of the biggest challenges facing cryptography is the rise of quantum computing. Quantum computers have the potential to break many of the encryption methods that are currently in use. To address this challenge, researchers are developing new encryption methods that are resistant to quantum computing attacks. One such method is lattice-based cryptography. Another challenge facing cryptography is the increasing use of artificial intelligence (AI) and machine learning. AI and machine learning can be used to break encrypted messages by analyzing patterns in the data. To address this challenge, researchers are developing new encryption methods that are resistant to AI and machine learning attacks. One such method is the homomorphic encryption. In conclusion, cryptography is a constantly evolving field that is essential for protecting sensitive information. As technology advances, new encryption methods and algorithms will be developed to keep up with the changing landscape. The role of mathematics and cryptography will continue to be crucial in the development of these new encryption methods and algorithms. Thank you for joining us on this journey through the fascinating world of mathematics and cryptography.